we have, sorry? What? Yes, no, I left them in on purpose. I left them in on purpose because I didn't want you guys to have to keep drawing things, because this one's got the same drawing sort of 3 times. So I thought I'll leave them in, and that way we can just look at it. All right, so this one, we're going to find the coordinates of the focus and the equation of the directrix for the parabola, x squared equals 20y. So we've been given that. Now, what format is it in? Cool. So from that, we can say, therefore, 4a equals 20, a equals 5. Yeah? Yeah, mate. Okay. The other thing we can get from that is we now know what the focal length is. Would you agree? Can anyone tell me what the focal length is? Yeah. Okay. That will become useful later on. Okay. Now, we still need to find the coordinates of the focus and the equation of the directrix. And there's a couple of different ways to do this. You can draw the graph, x squared equals 20y, count 5 units up and 5 units down, because that is the focal length. Does that make sense? So wherever your parabola is, if you go up 5, that's your focus. And if you go down 5, that is your directrix. Does that make sense? Because you've worked out what your focal length is. Cool? I'm going to take the absolute dead silence as a yes. Are we at 0? It looks like it on here. And if you have a look, that is the form we're in. And if we're in that form, then yes, our vertex is at 0, 0. Cool? And our axis is at x equals 0. Cool? That's the whole x squared equals 4ay. We get into the more general one later when we've got the x minus h and the y minus k. And that's where it shifts off the axes. Cool? But at the moment, yeah, 0, 0. So yes, what is your equation going to be? Your directrix, it's going to be y equals minus 5. Okay? And you can get that just from drawing it. Okay? You've drawn the graph. You have drawn the focal length up and the focal length down. Now, to be perfectly honest, notice how there's no numbers on the x-axis? Because it's just a sketch. You don't have to do table of values or anything like that. You can just draw it. You know the parabolic shape. And then you know, because it's in the x squared equals 4ay, you know that the vertex is at 0, 0. So you just count up and count down. So the directrix is y equals minus 5. And the focus, what's the coordinates? 0, 5. Because you know that that has to be in the form of 0a. And you know that this, and the thing is you didn't even have to draw it realistically, because you know it's got to be in the form of 0a. And it's also got, the directrix has got to be in the form of y equals minus a. Cool? Now, on the other page is method 2, and that's what I was just saying there. You can actually go, all right, method 2, it's in the form of the focus is 0a, therefore 0, 5, and the directrix is y equals minus 5, because so y equals minus a, therefore y equals minus 5. Okay, so you didn't need to draw it, but you could. All right, the second part of this question actually asks to find the points on the parabola at the end of the lattice rectum and find its length. Now the length is going to be easy because you've already worked that out. Okay, we're already given that, but that's all right. The end points of the lattice rectum. How do we know where the end points are? We know we need coordinates, right? So we need this point, and we need this point. How do we find those points on a parabola? Come on. Well, 4a will give us the length of that. Okay, you could do that. You could do that, and you will get the correct answer. Okay. I think you're doing... Yeah, okay. Well, unless the length is a square root, then you start to get a bit messier. So if you're looking for the coordinates, though, to be honest, you'd have square root of 2 over 2. So, yeah, you could. You could go, all right, well, I know that this length... yeah, kind of. That's all right, though. You know that length is 4a. 4a equals 20. Therefore, that length is 20. Yeah? So, therefore, your lattice rectum is, its length is 20. Cool? And that means it's 10 either side, which means one of your points is going to be minus 10, 5, and the other one's going to be 10, 5. Yeah? That does work. Can I show you the other way? No, thanks. Not the smart person way. We're going to do the mathematical wanker way. Because mathematical wanker way. Okay? Yes, that's the official term. Yes, but know this way just in case you get a weird answer and you want to double check. Okay? But, I mean, that's the thing. That's what it is. It is that. I think that the times you'll have trouble is where you're not on 0, 0. You may have more, it may become a bit confusing. Whereas this way will work all the time. So, what have we got? We've got a parabola, right? What's the parabola? X squared equals 20y, right? Okay, now we're trying to find 2 points. Yeah? And those points are where y equals 5, right? Yeah? So what do? We sub in. We go, okay, x squared equals 20 times 5, which equals 100. Whoop. Therefore, x equals square root of 100, which equals plus minus 10. Cool? Which means your coordinates are at minus 10, 5, and 10, 5. Yeah. Both get you exactly the same answer. Happy with that? How many of you can do it Nick's way? It is. It is more simple. It's not actually something that I sort of recognise because I'm a mathematical wanker. So I had to do that. That's what I was trying to get you guys. I'm saying, can you see? Can you see? I want you to see that the values here, the y values had to be 5, and therefore you just substitute in. And Baden, I'm sorry, you also said that you should substitute in the 5. You saw it. You were there. You were with me. We share a mathematical pedigree. Yeah, dumbing it down is great. Yeah. Exactly. Yes, ma'am. So that's the end of that question. That's the end of that question. There is another one on the next page, which is very similar, but it's got a chord rather than the directrix and the lattice rectum. Can I do this one first? If I'm quick? All right, tell me what I've got to do. Okay. X squared equals 4y, which is in the form of x squared equals 4ay. Therefore, a equals what? Yeah, 4y, 4ay. Cool. Okay, so what's my focal length? Is 1, correct? Which means that's my focus. And what would be my directrix? So I'm finding the equation of the focal chord. So I don't even need to. So there's my focal chord. See how I know, find the equation of the focal chord to the parabola. Now it's a focal chord. What does that tell you? It's a chord that goes through the... Yeah, read the other part. It's a chord that goes through the focus. Okay, so you now have a point that it goes through because they gave it to you, and you have another point that we just worked out because we just worked out what the focus was. Does that make sense? Okay, so now we've got 2 points. What do we do? Don't care about that. We're trying to find the equation of that line. That's what they want us to find, the equation of that line. All right, I'm going to say it again. I got 2 points. I don't have the gradient. I got 2 points. You could work out the gradient, but why can't I just use the 2-point formula? Does that sound all right? Okay. Do you guys remember what the 2-point formula is? Yeah, I did. Well, work out the gradient if you want. And then we can just use the point gradient formula. You want to do that instead? Because we prefer that. All right. Well, let's work out the gradient. What's your rise? You happy with that? So I did my rise over run. I didn't write the formula down this time. I just did it because you're adults. So now we can use this one. Yeah? Yes, you are. Yeah, I've done something wrong there anyway. I'll figure it out.